Okay, so probably up until now you've used degrees for like the measure around a circle, angle measure around a circle. So for example, for a circle all the way around 360 degrees. But radians is another way to describe the angle measure around a circle, and all the way around the circle in radians would be 2 pi. So we are going to look at how to go back and forth from degrees to radians, and something to kind of consider, like 1/4 of the circle would be 90 degrees, or halfway around would be 180, 3/4 would be 270. For 2 pi, 1/4 around would be like 1/2 pi, or halfway around would be 1 pi, 3/4 would be like 3/2 pi. And so on. So it's just a different way of looking at it. Radians are mostly used in physics, so it's important to be able to go from degrees to radians. Okay, so converting from degrees to radians, we're just going to use this formula here. Degrees to radians is this right here. Theta is our degree measure of the angle. So this would be 45 degrees times pi over 180. Okay, so you could just plug this into a calculator, but that's not how we're going to do this. If you plug it into the calculator, you're actually not going to get the exact answer that we need, because we need it in terms of pi. So what you would do is now simplify these numbers. So this would be 45 over 1, right? And then when you're multiplying fractions, you can simplify before you actually multiply. So any number on top and bottom that can be divided by the same number, we can divide it by that common factor to simplify it. So for example, 45 and 180, they can both be divided by 5, they can both be divided by 15, but the greatest number they can both be divided by is 45. So we can divide this by 45 to get 1, and divide this by 45 to get 4. And then the answer here, 1 times pi is pi, 1 times 4 is 4, so we get pi over 4. So if you were to plug this into a calculator, you'd get a decimal, but the answer choices are actually going to look like this. So it's important that you're just simplifying to find the answer. Okay, number 2, we're just going to repeat the same process, degrees to radians. So 65 degrees times pi over 180 degrees. And then simplifying those two numbers, I know I can divide both 65 and 180 by 5. So divide by 5, this comes out to 13. And divide this by 5, and it comes out to 36. So we get 13 pi over 36. It almost looks like we can simplify that there, but we can't. 13 is prime, and it can't be divided into 36. So. So far, so good? Okay, next one. Now we just repeat. 85 degrees times pi over 180. Okay, we divide both of these by 5. 85 divided by 5 is 17. Divide this by 5, we get 36. And then 17 pi over 36. And then just kind of considering these numbers, 17 over 36, maybe about 1/2. So this angle would be somewhere around like 90 degrees. And then for number 4, we have a negative number. No big deal, we'll just work with a negative number. Negative 225 degrees times pi over 180. And then we simplify just like we did before. Divide by a common factor. 5 stands out. 15 also works because 15 times 15 is 225. So divide this by 15, we get negative 15. Divide this by 15, and it is 12. Not it. Right here, negative 15 pi over 12 can still be simplified. Negative 15 and 12 can both be divided by 3. So negative 5 and 4. Negative 5 pi over 4. And this is our answer. Thank you, Hajir. The next set of questions, we're going to go from radians to degrees. So they're going to give us the radians, and we're trying to find the degree measure. The equation for this is theta, which is going to be the number they give us, times 180 over pi. So here we have pi over 3 times 180 over pi. Okay, so for this, we're going to, of course, simplify it before we do any multiplying. Pi divided by pi is just going to cancel that to 1. And then 3 and 180 can both be divided by 3. 3 divided by 3 would be 1. And 180 divided by 3 would be 60. So we get 60 degrees. Okay. And then we just repeat that. So number 6, 2 pi over 9 times 180 over pi. The pi's cancel. We're looking for a number we can divide both the top and a bottom number by to simplify it. 9 and 180 can both be divided by 9. So divide this by 9 to get 1. Divide this by 9, we get 20. And then 2 times 20 is 40, so 40 degrees. Next, repeat. The pi's cancel. 8 and 180. 180 can't be divided by 8, unfortunately, but they both can be divided by 4. So divide this by 4 to get 2. Divide this by 4, we get 45. And then 45 over 2 divides to 22.5 degrees. Yes?
Could you just do 180 divided by 8 just to get 22.5?
Yes, you could. And yeah. Number 8. Negative 3 pi over 5 times 180 over pi. Cancel your pi's. And then 5 and 180 can both be divided by 5. So we get 1 and, I don't know, what is it, 36, I think? Then negative 3 times 36 would be negative 108 degrees. Okay. Now we're going to look at how to graph these on a coordinate plane. Pretty simple concept. Just remember this is a theta, and it refers to the angle measure. This right here is the initial side. Something that's not drawn here is the actual coordinate plane, but we're going to look at that on the other side. So imagine coordinate plane here. This is actually your x-axis, and that's your initial side, and then you're just drawing an angle from that x-axis. And then from here, okay, so we're going to be looking at a coordinate plane. The initial side will be on the x-axis right here, and then we're just drawing our angle. Now, you've seen positive and negative angles. A positive angle goes this way. It's going to be counterclockwise. And then a negative angle will go clockwise. You may remember that from when you did transformations in geometry. Counterclockwise was positive, and then clockwise was negative. You remember that?
I don't.
Oh, you don't? Jeez. Okay, ready? No, I don't want to go too slow, but I don't want to go too fast either. Nobody's yelling at me. I'm gonna keep going. Okay. Okay, so on this page, we're gonna sketch the angles. So it says sketch each angle in standard position. So for number 9, we are going to draw a coordinate plane like this. Okay. So this would be like at 0, our initial side right here at 0 degrees. And then one turn would be 90, 180, and then 270. So the first angle we're graphing is 135 degrees, which would be in between 90 and 180, of course. But specifically, 90 plus 45 degrees is 135, so it's like exactly in the middle there. So I tried to draw it as best I can, but there it is. And then we just draw a little arrow to show that direction.
How do you know it's in the middle?
What's that?
How do you know it's in the middle?
Well, this is 90 degrees, so half of that would be 45. So 90 plus 45 is 135, so that's why I drew it in the middle. Repeat. Next one. Number 10. Again, coordinate plane. And this initial side will be right here at 0. This one's negative, so it's going to rotate in this direction. So as I label these, I'm going to use, like, this would be negative 90, negative 180, negative 270, and like all the way around would be negative 360. Okay, so we got negative 315, so it's literally all the way around 270 plus more for 315. 270 plus 45 is 315, so again, it's going to be right in the middle, right here. And it's going to go all the way around here, so negative 315, all the way around like that. It's odd.
It's weird.
The way it labeled that was kind of weird. I don't know. But I was trying to show that circle thing. Okay. Oh, it's still recording. We're going to graph these, and we're going to graph them using radians. In the last class, I changed it into degrees before I graphed it, but we're going to challenge ourselves to just graph it from this. So, coordinate plane. Like this. We have our initial point right here at 0. And then, so each part, so remember it's 2 pi all the way around. So each part, this would be like pi over 2. This would be pi. This would be 3 halves pi. And then 0. Which would be 2 pi. Okay, so graphing 7 pi over 6. Like 6 pi over 6 would be pi right here. If it was 6 pi over 6, it would just be like 1 pi, which would be 180. 7 pi over 6 would be like 1/6 more. Like if this was broken up into 6 pieces, like if this whole half was broken up into 6 pieces, we need 1/6, so like 1/3 of this piece. So I'm going to draw my thing right here at right here. And then there.
How do you know what to label it?
So 2 pi was all the way around, so I just like divided 2 pi by 4. So 1/2 pi would be like 1/4 of 2 pi. And then it'll be the same like every time. Okay, now let's try a 12.
That's weird.
It was weird. Does it make sense though?
Kind of.
Kinda?
I think I can do it.
You have to think about it.
You have to think about it hard, yeah. I agree. Even I had to think about it hard. Okay, 12.
It's just a different way of doing it.
Yep. Okay, so here we got our initial right here at 0. Then we have pi over 2, or 1/2 pi, pi at 180, 3/2 pi, and 2 pi. Okay, 5 pi over 3. Well, 3 pi over 3 would be right here. So we need 2 more parts of 3. So if we broke this into 3 parts, like I could kind of do that with a pencil. Broke it into 3 parts. So we got 1 part, 2 part, 3 part. Then this would go right here. 5 parts. And it goes all the way around this way. I just made your brain think even harder. Okay. So this is pi. So if we broke this up into 3 parts, so we need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 parts to get there. I don't know. How's that feeling? Is there a better way to say that?
I have no idea.
Well, worst comes to worst, let me show you the other way in case you just feel more comfortable.
How would we do it if we had to change it?
Yeah, so if you need to, you can turn it into degrees. If this doesn't make sense, then just turn it into degrees. So you can go from radians to degrees times, what was it, 180 over pi? And then do that whole process we did on the other page. So cancel the pi's out, and then divide this by 3 to get 1, divide this by 3 to get 60, you get 300 degrees. And then you could graph 300 degrees, which
That's
would
a
be,
little bit easier to look at.
that's cool.
It takes extra work, but it's
See,
easier than
yeah,
looking.
that's fine. Okay, so worst comes to worst, like if this isn't making sense to you in your brain right now, that's cool. Just turn it all into degrees, and you can work it with it that way. So 180 over pi, cancel out your pi's, divide by 6, you get 1, divide by 6, would be 30, I think. Yeah. 7 times 30, 210 degrees. And then this would be at 210.
Are we gonna have homework tonight?
See, okay, one more concept. Okay. Okay, coterminal angles. I'm going to teach the process of how to get the precise answer, and then I will explain what that answer really means. We're going to find 2 coterminal angles. What we do to find the coterminal angles is we're just going to do 120 degrees is the angle they gave us. We're going to add 360 degrees, and then we're going to subtract 360 degrees. We get 480 degrees and negative 240. That's the process, and it is that simple. What the heck do those angles even mean, though? Let me show you. So here's a coordinate plane. Okay, if we were to graph the 120 degrees, remember this is 0, 90, 180, 270. So if we were to graph the 120, it would be right here.
So are they just both gonna end up at the same?
Good call. Yes. Okay, so who's talking? Can you stop talking, please? Okay, so this would be 120. I'm going to quickly just kind of label that there. That's 120. Coterminal angles end up at the same spot. So negative 240, if you from this angle and you went to negative 240 around here, it would end up at the same spot. And with the 480, so if you start here, you go all the way around once, and then an additional 120, it'll land at the same spot. So if you go all the way around and an additional 120, it lands at the same spot. So this would be the 480 degrees. Same idea, same process. Now we're working with a negative number, but it's still the same process we do. Negative 350 plus 360, and this number minus 360. So we get 10 degrees and negative 710 degrees. So if we were to graph that, there's our initial one. Okay, so we have our initial side, the negative 350, so this would be negative 90, negative 180, negative 270, okay. Negative 350 would be like over here, all the way around. Negative 350, like this. That would be the same as 10 degrees this way, which would be the same as, here we go. Are you ready for the spiral? 710 is going to go around once, and then an additional 350. Okay, negative 710. Okay. Okay, this one, same concept. Now we're dealing with radians, but all the way around is 2 pi. So for pi over 3, we're adding 2 pi, and then we're subtracting 2 pi. But when we add or subtract fractions, we need a common denominator. So we're going to multiply both the denominator and numerator by 3 here on both of them. So we get pi plus 6 pi equals 7 pi over 3. Bonito. And then pi minus 6 pi equals negative 5 pi over 3. Yes, I'm working faster because I feel like everybody's just getting bored and we just want to be done at this point, so I'm working on it.
Can't you just like change it to the angle though and then add and subtract 360?
Sure, but the answer choice might look like this.
Oh.
So if that's the way you were doing it, then you could test out the answer choices to see if you get the same. I guess you could translate that.
And after you add 360, you just change it back.
Yeah, you
That
could.
would work, but-
You could. Yeah, but if that makes you comfortable, or if that's the only way you remember on like a test, then sure. 16, same idea. Negative 5 pi over 6 plus 2 pi. And then negative 5 pi over 6 minus 2 pi. You need a common denominator, so we'll multiply this by 6. What?
Was still finishing up the orange.
Oh, sorry, my bad. I was just trying to get it done because we bored.